Okay, there's an inequality problem that we need to solve on the upper left of the screen. But before I attempt to solve this, just let's go over a few things that you need to note that would be very helpful. This is considered a less than sign. This is considered less than or equal. This is considered a greater than sign, and the one to the right is this symbol is greater than or equal. Let me make a couple of notes. All right, when you're reading an inequality, let's say we have 3 is less than 5. So if we're reading from left to right, it is true, 3 is less than 5. But if you choose to read it from right to left, then it's 5 is greater than 3. So 3 is less than 5 can also be written as 5 is greater than 3. Notice that I switched the sign, the direction of the inequality sign, when you switch the numbers. So if you have 2 is let's say 2 is less than or equal to x, it's easier if you have an x in your inequality to put the x on the left. It's much easier to read. So if 2 is less than or equal to x, then x is greater than or equal to 2. Okay, for the next note, I want to do something to both sides of these inequalities. So in the first case here, I'm going to add a positive number, and let's see if it maintains the inequality. What we wind up with then, that 8 is less than 10, and that's still true. Let's try the next one. Instead of adding a number, I'm going to add a negative. I'm sorry, I apologize. Instead of adding a positive, I'm going to add a negative number to both sides, and let's see what that produces. So that makes 4 is less than 6. That is still very true. So we know so far that we can add a positive and add a negative to an inequality to both sides, and it maintains the true inequality. The inequality is still true. Well, let's try multiplication. Let's take let me try it in a different color so you can see. Let me multiply this by 2 and this by 2. So I'm now taking an inequality, I'm multiplying by a positive number, and in this case I'm going to multiply by a negative number. And in the third case I'm going to multiply by 0. So let's see which ones of these following ones are true. Okay, so in this case 12 is less than 16. That's still true. Let's look at the next example. Negative 12 is less than negative 16. That is false. Now, I'm going to put a line through this to tell you that it is not true. So this is the case we have to worry about right here. When you are multiplying by negative, it makes the original false. Let's see what happens when you're multiplying by 0. Multiplying by 0, you get 0 is less than 0, but that's not true either. So this was false, but I put a line through it, and now it is a true statement. So from here, these are the two things we have to worry about. We have to worry about this one and this one here. Everything else works. All right, let's look at the next row. In this case, I'm going to divide by a positive number, divide by a negative number, and then see what happens. So I'm going to divide by a positive number, and we wind up with 3 is less than 4. That's true, not a problem. We can divide by a positive number. In this case, let's divide by a negative number. Does this maintain the true statement? Well, let's see. Is negative 3 less than negative 4? And that is false. We're going to put a line through it to say that it is a false statement. So we have to worry about this guy now, too. We have to worry about this one as well. Let's look at the next example. you know, if I divide by 0, I mean, that's just simply ridiculous. That's undefined. I'm not even going to deal with that. So let's go back and look at when the inequality became false. All right, so let me write that up. When multiplying or dividing both sides of an inequality by a negative number change the direction of the inequality sign. And of course, the problem with also multiplying by 0 will also make a false statement, except in one case. So let me just review that. If you have 0 is less than 8 and you multiply by 0, certainly 0 is not less than itself. That's false. But if you start with the inequality 6 is less than or equal to 8, that is a true statement. Let me fix that. But if I multiply this by 0 on both sides, I get 0 is less than or equal to 0. This is true. So this only works when it has a less than or equal sign. Okay. So please pay attention to this rule right here. It'll come in handy when we want to solve that original problem. And let's get back to that right now. Okay, here we are. 5x minus parentheses 3 plus 8x, close parentheses, less than or equal to negative 18. Your goal is to solve for x. Again, if you see a parentheses and a subtraction sign in front of it, put in the imaginary one. Okay. What do you do first? Well, the rules for solving equations will not change. You distribute first, collect like terms, and then apply the new rules for inequalities. Okay, so here we go. This becomes 5x minus 3. You're going to distribute twice. So that's minus 3 minus 8x less than or equal to negative 18. So we distributed just like before. Now we're going to collect like terms. There we go. So it becomes negative 3x minus 3 is less than or equal to negative 18. All right. We're allowed to, or it's legal to add a number to both sides of an inequality, and it maintains its true statement. So I'm going to add 3 to both sides, as we mentioned before. And we get negative 3x is less than or equal to negative 15. But now we have a problem. To solve this, I'm going to rewrite negative 3x, but we need to divide by negative 3. I'm going to leave the sign blank for now, or the direction blank for now. And we get negative 15 divided by negative 3. When you divide both sides of an inequality by a negative, we know that we must change the inequality sign. So let me put the change right here, and we've changed it. Now I'm going to reduce each fraction, and I wind up with x is greater than or equal to positive 5. If you are asked to graph this inequality, x is greater than or equal to 5, you would have to draw a number line. There's your 0. It's 1, 2, 3, 4, 5. Now, it's all real numbers greater than or equal to 5. So in this case, at 5, I'm going to draw a closed circle, fill it in, and then in which direction do we go? We go in that direction. That would indicate that the solution to this inequality is an infinite set of all real numbers greater than or equal to 5, starting at 5 and going to the right. Okay, here's a simple inequality. Let's solve for x. Well, we first want to divide by 5. Subtract 5. And you're left with, don't forget to bring down the negative sign. So this is negative x. It's really negative 1x is greater than 2. So to avoid a common error here, remember to bring down the negative. Okay, I'm going to rewrite the problem and divide by or multiply by a negative 1. You choose which one you prefer. So it's negative x and 2 And, let's multiply by a -1. Why? Because -1 times -1x does produce a positive x, which is what we're solving for. And we have here also multiplying the other side by -1. So a negative times a negative is positive x and -2. Now what happens when you multiply both sides of an inequality by a negative? Remember to change the direction. I'm sorry, I said change, and of course it was greater than, so change it to a less than. All right, now, if you wanted to graph, if you were asked to graph this solution, you would draw your number line. So if this is 0, then this becomes -2. Now, we want to graph all real numbers that are less than -2, not equal to. So in this case, you have to have an open circle. Do not include the -2, but you want everything now to the left. Okay, in the next example, it should be a one-step solution. So we're going to subtract 2 from both sides, and you get 4 is less than x. Well, it's so much easier to have x written on the right for graphing purposes. It's just easier to think about. So we learned before that if a is less than b, then if you want to rewrite it, b then has to be greater than a. So if 4 is less than x, then x is greater than 4. So if you want to graph this, this is 0, this is 1, 2, 3, 4. You put your 4 there, but the answer has to go, when you're graphing, first of all, it's strictly greater than, which means open circle. You're not including the 4, and you're going to the right. So it's not the sign that you look at, it's what it means. So 4 is less than x means the same as x is greater than 4, and this is the correct solution. All right, there's one more example that I'd like to show you that will include a common error, and here we go. Why don't you try example 3, pause the video, and then come back and see if you got the correct answer. This one has a couple of tricks to it. Okay, so the solution for example 3. First thing we want to do is distribute by that -1. So we wind up with 6 less than or equal to 2x minus 5x minus 3. I distributed by that -1. Collecting like terms on the right side, I get 6 is less than or equal to -3x minus 3. It's legal to add 3 to both sides, and it maintains the true inequality that we started with. And we get 9 is less than or equal to -3x. Okay, so what happens now? Now we have to, well, there's that pesky -3 again, so I'm going to divide by -3, divide by -3. What happens when you divide? Don't forget to change. If this is less than or equal, we're going to change it to greater than or equal. And I'm going to rewrite the problem now as -3 is greater than or equal to x. Again, I think I made a mistake before and said x was on the right, or I wanted it to be on the left, and I said whatever. I said it wrong, so now I'm going to say it right. It is so much easier for graphing purposes to have x on the left, and so I'm going to do that. So if -3 is greater than x, I can rewrite it as x is less than or equal to -3. So if I'm going to graph this, (1, 2, -3). This is 0. The answer will be, we're including the -3, so it's filled in, or a closed circle, and we go to the left.